All right, welcome to a early morning video. Gotta get somewhere at 8, so let's make the most out of the morning and prepare for my job on the 25th. So to do that, we're going to continue with this pexpect. Unfortunately, I'm having trouble connecting to that second router. The lab wants you to, the topology, they actually didn't list their they just wanted you to import a file to set it up in Viral, but Viral is like $200 a month. And that's a bit expensive for me because I plan to use my networking server for more than a month, probably more than 3 months, probably even a year, which is 12 months. And for $200 a month, that really adds up fast. So I'm actually not sure it's $200 a month. It might be per year, but even if it's per year, like I'm probably going to be able to use my server that costs $600 for at least 3 years. So it's equal price. It might even be less if I use it for longer than that. But one of the things they want you to do in this lab is set up management to these two devices, like in a topology that I gathered was kind of like this. But I mean, it could have been different where it's just one link to router 1 here, and then there is a management network connecting these two. But I think I'm going to kind of stray from the path, and I'm going to just use a different network for management to router 2. I think that's the easiest, most straightforward way to do it, which is kind of what I'm all about. All right, so, okay, we're good to go. So let's take a look at the IP on there. And we can see it's going to be .1.21. Let's change it to .2.21 so that it's on a different subnet. Before we do that, though, let's just look at the config again, because I'm just curious what they wanted from it. Okay, so if they included this in there, I would have been kind of more supportive of the configuration they have, but unfortunately, they did not. So, and this might be like a special Viral thing where it has to be configured this way, like the fact that it's in a VRF so that Viral can do things under the hood. I don't know, but I don't, I think, have the capability for, oh, I do have VRFs. Okay, well, you know what I'm going to do then? I'm going to configure it the way they said to configure it, using a VRF. So VRF definition, and then yeah, I'm just going to do that. So let's see here. So IP VRF, and then it's going to be MGMT 9TF. Yeah, and this will be good too, because then when I look at the routing table, all that sort of thing, I won't see this route in there. It won't be cluttering that up. So here they just have address families. That's all they have listed there. Address family IPv4. I don't see the option for that. For address family IPv4. So I'm not sure what they want me to do. Well, I think it's already kind of, I'm losing too much time doing this, so if I just change that IP, I'll be up and running. So that's all I want, is I just want to get up and running. So yep, I'm going to set this to .2. The thing that's kind of nice about Cisco's is you don't have to delete the configuration. It'll just overwrite it. You can still put secondary, put multiple IP addresses on there, but you've got to use that keyword secondary. So it's just a little bit quicker and easier to configure, but it's that can be its downfall as well, because it's quicker and easier to cause a problem. Concurrently to this, I'm doing a series on the JNCIE SP, and as I've said multiple times in that series, I really prefer the CLI Junipers to Cisco's. All right, so I think we're good to go. Maybe this can be smaller. Yeah, there we go. So now let's open up a terminal. All right, we're going to need to change our IP now because it's on a different network here. I don't know why this shows up and that other one doesn't. I think it's because they're on the same subnet, and as such, it has to choose one interface or the other. It can't use both when they're on the same subnet, and that's why I was having that issue where I couldn't ping .21. Like I don't know how in their lab they're able to use it on the same subnet, but I don't think that's going to be possible in my lab, and I'd be really surprised if that'd be possible in the real world production. So maybe it's something specific to viral. It needs a setup that's not, you wouldn't see in the real world. Maybe it's a typo in the book. But let's try to get this to work. I don't know why this number 1 shows up. So the address got set to .1.2 somehow. It looks like it's difficult to get it to, so here we go, remove connection profile. I think you've got to do that first. You've got to essentially remove the configuration before you add new ones. So yeah, now we see the configuration is blank. So now I can add a new configuration. You can't do that if you haven't removed the configuration. Even though you hit apply, it will not actually apply the changes. But now I believe it did, so let's test that. Okay, so it just took a little while for those changes to go through. But now you can see we've got connectivity to that. Let's make sure we can telnet into it. And yeah, telnet is kind of, as I've complained about in the previous videos. And then hopefully, because one of the big things I've been trying to do and make these YouTube videos is make this as pleasant of an experience for my viewers as I possibly can without having to spend a ton on an extra camera and an extra recording device. But I had this just laying around the house from when a few years ago I wanted to record myself learning music stuff. So I just got to plug it in. It is already turned on, so. All right, hopefully that's a huge difference and I sound much better. So let's keep going. Let's see if I can get SSH to work again. Last video we saw there are huge problems with SSH. The main problem being that these Cisco images I'm using are unfortunately quite out of date. The copyright for them would have expired in 2005, so I'm sure these are older than 2005 because they're not going to be released on the very last date of the copyright, or they might be exactly 15 years old. I'm not sure, but this is kind of the key problem when working with GNS3. You can't, it's difficult to get Cisco images to work with because there are strict rules about copyrights, licensings with Cisco, and violating those rules can make you lose your certifications, subject you to all sorts of really unpleasant disciplinary action. So it's definitely not ideal for that reason. That is a reason that Viral is a better platform to use. You don't have to find your own images. They will give you your images. So that is a big advantage over Viral. But for me, the extra cost of Viral so far has not yet made it worth it to me, especially since in my previous position that I'll be moving on from. So I might want to see if my new employer can pick me up a copy of Viral if they already have Viral or something like that. But in the meantime, I'm happy to use GNS. It's just fine. But the main reason I haven't really kind of had to use Viral is I've worked with Juniper routers more, I would say, in the second part of my professional experience. First part, I worked a lot with Cisco's. And then, of course, I went to networking school and learned Cisco's. I did not learn Juniper's there, but I studied on my own and got the JNCIP or service provider. Okay, so let's see here. Crypto key generate RSA. We're gonna go 2048. Okay, and now we're gonna try this command again. And I have a feeling we're gonna get that rejected due to the cipher. Yeah, so no matching key exchange method found, their offer. So we can change our offer by doing hex algorithm equals Diffie Hellman group 1 SHA 1. So, oops. I gotta look it up, unfortunately. Let me see if it's still in my history. It's not. So I thought it was like Kex algorithm. I'll look it up. So what was the error message again? Just have it come up here first and foremost. No matching key exchange method found. So one thing I was trying to do last video, where I spend probably most of the time on the video, is the reason we're getting that message is because these images are so old, they don't even have modern SSH anymore, and I installed a fresh installation of the latest version of Ubuntu. So I've got to enable backwards capability on it. Oh, that was the problem. I never specified the host I wanted to log into. Oh, yeah, I did. What the heck? Hex algorithm. Oh, it is Kex. Aha, Kex algorithms. I thought it was a K, not an H. Because I remember it being like, what's a Kex algorithm? I know what a hex algorithm is. Okay, so now we got to specify the cipher as well. So let's just go with the first one. Okay, and now we can get SSH to work. Since we're using a legacy version, this Ubuntu server has backward capability, thankfully, but unfortunately, I couldn't find a way to make it the default capability, which kind of, I'm glad you can't, because I wouldn't want the default capability to be something unsecure. I guess I'm glad you have to put in extra things to say that you want to do something that is not recommended. All right, so yep, the SSH is working, Telnet is working. Now that we're using different networks for those two links, I don't know why they thought you could use the same network. Maybe it's something specific to viral, but let's move on. More pexpect features. In this section, we will look at more pexpect features that might come in handy when certain situations arise. If you have a slow or fast link to your remote device, the default expect method timeout is 30 seconds, which can be increased or decreased via the timeout argument. So let's take a look at that. Expand this. So if I did a py, and now here's something really interesting that I will demo for the video. I'm going to open a Python terminal. Python 3 terminal. And we've got Python 3.6.7. So let's import the pexpect module. Import expect. And okay, I wasn't expecting that to happen. So the point I was going to make, and maybe pexpect is part of the standard library or something like that, was that we have not activated our virtual environment yet. So, oh, it's not source, it's BNB. It's source in Linux land. Or sorry, not in Linux land, in Windows land. Do I have BNB? I do have BNB. Python 3 BNB bin activate invalid syntax. That's interesting. What the heck? Oh, maybe I never deactivated it. Let's take a look at that virtual environment some more. The example they gave us for how to enable that. See, this is a big reason why I haven't used in my own private projects, especially in the beginning. Like I started using them more later, but generally I haven't been using virtual environments because it's just, for me, I found it's one thing after another. Like, oh, I see. Okay, it's source BNB bin. I knew source was somewhere, so perfect. Okay, we're good to go. So the point I was going to make before was that you can't import a package that has been installed into your virtual space, but not into your global space. And that's the whole point of having that virtual space. But in this case, it was able to be imported from the global space, so it was probably there already. or it's a part of the standard library. I'm not sure why I was able to do that, but I'll do that for Paramico. I'll do that same demonstration because that will definitely not be in there. And I can even do an import Paramico right now. And yeah, there's no module named Paramico. This is a module not found error. So that's kind of an example of that. All right, so let's import expect. Before we do that though, let's clean up our script. So yeah, this chapter 2_1 script. Let's clean this up to be what is going to be the new IP. And then let's rerun that again so we can see that in its full glory. So yep, now we get back fairly nice and clean output from the devices. Really easy. You can already kind of see the power of this sort of thing to do like a network analysis. You want to know the software version of all your devices. Well, just use this script and create a comma-separated spreadsheet that shows all of your host names, IPs, and software versions. Really easy. Anyone can do that, even with just a few minutes or hours of introduction to Python automation. And granted, this is through Telnet, it's not through SSH. So this is assuming a unicorn environment, which in this case would actually not be a unicorn environment because it would be an environment where a lot of really serious things with network security are happening or are not happening. But just that simple example of being able to log in and pull back data from multiple devices, you can see how that would scale. There's no problem with doing that for tens of thousands of devices. All right, so import pexpect, and then we're going to do child.expect. Just to type it out, it won't actually work because we don't have the connection established. We're just going to learn about this argument that we're sending to it. And remember from the last video that there's a parameter and there's an argument. When we're defining a method or a function, we're including parameters between those parentheses because we're telling the function what it can take, what its parameters are. But when we're running a function or a method, we're giving, between those parentheses, we're giving it arguments because we're sending information into that function, and that is called an argument, not a parameter. All right, so let's see more about what could go into this as an argument. So let's take a look at the parameters. Oops. Oh, right, we didn't define child. Well, let's save that and do it for later. Let's just continue reading. You can use the pass command back to the user using the interact method. This is useful when you just want to automate certain parts of the initial task. Okay, so it looks like they're kind of assuming that you have done the previous steps, like way back. Yeah, they're assuming you've done everything all the way up until there. So let's just do that quick. It would be good to get under my fingers. So yeah, we're gonna start here, type all this, and then be up there. Fortunately, I've only got about 10 minutes, but I think just the exercise of having this under my fingers will be worth that 10 minutes, even if I don't get to go on farther, and then I can continue this line of thought after my thing I want to go to at 8, and then And then I can do work on my JNCIE later. I'm not sure how much I have typically worked on the JNCIE during the weekends. I'll go back, and that's the reason why I'm putting it all up public on YouTube. One, I can go back, look at it later. Two, if anyone wants to learn from me, I'm happy with them doing so. I'd love to help. Please do. Please take full advantage of this public series and learn everything you can. And three, I have a record of my study habits. I have a record of whether or not I'm studying fast enough. I have a record of the content I've looked at and the amount of depth I've put into that content. That's something you don't get if you're not recorded on video. One thing to notice about this is that we're expecting this password to be there. So let's say you didn't enter your password in time. So it resets back to asking for your username. So the time you spend between these commands potentially matters, because you could be expecting the device to give you this string here. But if I just wait for a minute, then send it, the device could have timed out and went back to the welcome screen, and all of a sudden this string won't be there. So it's definitely a pretty flawed method of communicating with the device. Oh, example, why did I say that? Expect. Okay, so we got everything as they do. Let's keep moving on. Oh, and they want me to exit. I'm not going to do that. All right, but I think it should be good to keep working. So this is the page I left off on. So now we can keep working where they are. So we can do a child.send line, show version, type include, capital V. Now we can do a child.expect IOSV-1, and then a child.before. That's what we just did. Now we can do a child.interact. That's the new command. Wish they had put that in bold, but apparently they didn't. Whoa, okay, that's cool. Well, it kind of can be cool, because one thing that becomes painfully obvious is that you have problems with where the output goes. In Python, when you print something, where does it print? So if you're doing this child.interact and you want to do Python code, your Python code might not necessarily be sent to the device anymore, because you're in that child.interact shell instead of the regular Python 3 chevron shell. So if you want to do a print statement, you're going to have trouble doing that if you're on the CLI using this method instead of down there. Not to mention, so there's something called synchronous code and there's something called asynchronous code. Synchronous code, you have multiple lines of code. It just goes through each line and it keeps going. Synchronous code, so synchronous code, it goes through boom, I'm running this line. This stuff can't run until I'm done. Okay, I'm done. Now this stuff runs. Asynchronous code, boom, I'm learning this line, but you guys can keep going. It's not fine. Okay, I'm done. Okay, you're still going. Fine. So synchronous code, the program stops during every line and waits for that line to complete before executing more lines. Asynchronous code, the program does not wait for a line of code to complete before executing more lines in the code. So if this is synchronous code and we're using this child interact, we cannot enter in any more Python code until we have stopped using this child interact. So in order to use Python and that child interact together, it's got to be asynchronous. There's also parallel, which is like using threads and multiprocessing, but that's a bit more advanced of a concept. So you can get a lot of information about the child.spawn object by printing it out in string formats. The most useful debug tool for pexpect is to log the output in a file. Child equals pexpect.spawn telnet 72.16.1.20 child.log file equals open debug wb, guessing means the. So use child.log file equals open debug w for Python 2. Python 3 uses byte strings by default. For more information on pexpect features, check out something I can't see. Oh, it's on the next page. So I do not want more information about pexpect. As I mentioned in many videos, I'm very disappointed at this book for introducing pexpect first, because there's really no reason to use it if you've got Paramiko, NetMiko, all sorts of better things. We have been working with, not to mention Telnet, oh my God. We have been working with Telnet so far in our examples, which there's a typo, which leaves our communication in clear text during the session. In modern networks, we typically use secure shells, SSH, for management. In the next section, we will take a look at pexpect with SSH, pexpect and SSH. If you try to use the previous Telnet example and plug it in with an SSH session instead, you might find yourself pretty frustrated with the experience. You always have to include the username in the session, answering the SSH new key question, and much more mundane tasks. There are many ways to make SSH sessions work, but luckily pexpect has a subclass called pxSSH, which specializes in setting up SSH sessions. The class adds methods for login, logout, and various tricky things to handle the different situations in the SSH login process. Let's generate the SSH keys for iOS v-1 for SSH. So we already did this. It's going to be different. It looks like they used that general keys command, oh, they're not. Yeah, I can't see whether they used SHA 1 or 256. Ours, we had to use SHA 1. The procedures are mostly the same with the exception of login and logout. Let's try to get to here before I need to leave, and then we'll call the video there. If it will allow me to resize my windows in a way that is convenient for me, that would be great. It is not. All right, there we go. So let's start a fresh terminal, and then do Python and from pexpect import pxSSH child equals pxSSH.pxSSH. So the name of the library is pxSSH, but the name of the class
It could also be a function that we're pulling in is also named pxSSH. Login 172.16.1.20 Cisco auto prompt reset equals false. Something did not work there. Yeah, I have a feeling this is going to be really hard. So let's get some help on child.login. Oh my god. So we've got the server, username, auto prompt reset. So we've got all the things. It looks like we don't have to include, yeah, these are not positional arguments. We've only got one positional argument. So I'm not sure what's wrong about this. Oh, okay, I forgot that. God damn it. Okay, so we still got the error. Let's do another help. Actually, let's stop it here because I have a feeling troubleshooting this sort of error SSH and pexpect is going to be quite a bit difficult, but I think I can get through it. I just got to figure out how to use that kex algorithm flag and then the cipher flag as well in pexpect, but this will be a really good lesson on how to use help in Python to figure that out. So stay tuned for more, and thanks for watching.